Hello everyone, and thanks for joining. My name is Derek Kane, and today we're going to talk about getting up and running with R in RStudio. This lecture is one part of a broader series of lectures talking about data science, predictive analytics, and machine learning techniques and technologies. The overview of topics we're going to go through today will include an introduction to the R language. And this introduction will be very brief, but I think it captures the essence of R. We'll talk about installation and configuration, how to install the software and get the tool in place so you can begin working. I'll jump into some RStudio basics, working with RStudio, moving through the navigation panes, what the menus are within the software itself. Then we'll shift gears and we'll talk about R script development. And working in predictive modeling and machine learning in R will require a lot of emphasis on developing your R script. And I want to just kind of go through some techniques that will help you to be successful in the long run. We'll talk about installation of packages, talk about R modeling components, and then finally, I'll go through some broad additional R tips that may help get you up and running and reduce the learning curve of working with the R language. Thank you very much, and let's go ahead and begin. I am slowly becoming a big advocate of the R language. Now, I've spent most of my data mining, my predictive analytics work in SPSS and in SAS. My graduate studies was primarily focused in SAS, but I wanted to make sure that I had the ability to take my knowledge base with me wherever I go. So the open source platform of R was really appealing to me immediately. What I like about it is there's no upfront cost for using the technologies from a business perspective. If you want to get into predictive analytics, but you don't want to spend thousands of dollars on SaaS user license, this is a way to get your feet wet. It's open source. Being open source, there's no mysteries, there's no proprietary lockdown into a specific tool. Having an Oracle database means that you generally are going to have Oracle-based products that supplement for your reporting, for your BI, and when you have issues with it, you have to consult with Oracle directly and hire consultants to come in and reconfigure the system, and you're not locked into one proprietary tool's solution, if you will. And I think that's actually an advantage of R. It is the most powerful statistical programming language in the world. So this is not, just a simple, kludgy piece of software that's out there. This is being used in major enterprises. It's easy to share across a business. Taking the code that one person is developing, or an R script, and passing it to somebody else and having them run it is seamless. So to share work is very simple to do. Due to the manner in which the R language processes data with the in-memory computing, it's often that it works better or faster than Microsoft or Oracle products for data and analysis. Now, recent advances in Microsoft SQL Server, I believe in 2014, they have some in-memory processing components, and I believe Oracle has some as well in their big data capabilities that are now closing that gap. But for a while, R had a leg up on the competition. A great feature is the fact that it is infinitely customizable to your problem and your products. Vertical integration. So whether you're a nonprofit, a finance company, you work in the public sector, you're a brick and mortar, or your software as a service company, you can take R and you can mold it into working for the problems that suits your line of business. Okay, and because of such, you can integrate it everywhere. There's a very large support group of users worldwide. And I can't stress this enough. When I run into a problem with programming, let's say a question about an SQL query or some type of statement that I'm trying to figure out, I go to Google and I run a search. When I run this search, I go to the message boards, and it is sometimes very difficult to find information I'm looking for. You enter these battle zones of individuals, competing to say, whose ego is greater than the other, and that you actually can't find what you're looking for. The R user community is completely different. They are willing to help you. If you have a question concerning some type of technique or a process, there's a very good chance that somebody has already had the same exact question, and they give a detailed explanation of why they're using it this way, and it's a very inclusive society. Another aspect is that it really is the most widely used data analysis software. So not only is there a large group of users worldwide and growing, it's the most widely used. And I think in the upcoming years we're going to see an explosion in the adoption of this technology. Okay, so if I was SAS or SPSS, I'd be very concerned. The software originally was used in academic purposes. It was used by researchers, and because of this, the base packages and the base statistical functions had to go through a very rigorous vetting process. So the quality of the statistical results is very high, and when people develop new packages and new tools for R, it's highly credible due to the standards for submission, and the user community will go about and help to improve the quality of the products. So if there's a bug or something with an issue with a technique that has been developed, a lot of times you'll see the user community reach out and try to make the correction. Finally, R is relatively easy to learn. Now I say relatively easy because if you've never programmed before, or even if you are an experienced programmer, there is a substantial learning curve. Once you can get past this learning curve, then everything will click and you will understand really how to work problems in R. It is relatively easy to learn from my point of view, but not everybody will agree. I think it's important when we're talking about the R language is to relate it to topics that we understand a little more deeply. One way to approach thinking about this language would be to compare it to the language of our smartphones. The iPhone iOS interface has a lot of incredible built-in features that are native to the phone. Apple provides us with a Safari web browser. We have our iPod music player. There's alarm clocks, quick menus, etc. So in the Apple iPhone in and of itself, there's a lot of useful features. However, the real power of the iPhone is unlocked through the use of third-party applications. Using a Facebook app, a Twitter app, our Google Maps, for instance, weather.com, Plants vs. Zombies, etc., etc. In this regard, R is very similar. Instead of running applications, we install the applications and call them packages, and then we run them when we need them. And when we're running them in the R language, we call these libraries. So think of R as kind of an operating system in an ecosystem, and I think just conceptualizing it that way will help. The key to being a great R user is to know which packages and libraries to run in tandem with each other for a specific machine learning and predictive modeling task. And that really is the secret. The next section will walk through an installation of the R software for somebody who's never touched R before. So if this is something that you're comfortable with, feel free to move along to the next section. Otherwise, sit back and enjoy the show. First things first, we're going to go to Google and we're just going to run a search for R. When we run a search for R, we get the URL address of www.rproject.org. We want to go ahead and click on that. Once we've clicked on the hyperlink for R, it opens up to a main menu that kind of looks like this. If you're looking at this, what we want to do is we want to find the section in the Getting Started, and there's a link for Download R that we want to click on. So go ahead and find that link and click on that. This should take us to the Crayon Mirror section, and all the mirrors are doing is showing us where we can download the source software from. So select the mirror of your choice. In this case, I just selected the RStudio mirror, but go ahead and click on that. When we do this, we're going to have the option of which version of R do we want to install. Now, all of the work that I'm doing here is in a Windows environment, so if you are using a Mac or a Linux-based system, go ahead and select the link of your choice, but just understand that everything that I'm talking about moving forward is Windows-based. Once we selected R for Windows, go ahead and click on Install R for the first time. When we do this, a prompt should open up that allows us to download the latest version of R. In this case, it's 3.1.2, and go ahead and click on that link. Once you've done this, you should receive a prompt that is going to try to download and run the file. Go ahead and select Run. When you do this, walk through the setup configuration and set it up in the manner that best suits your needs. And I'll talk about a couple ways to set it up in the next slide. I would recommend installing the core files, 32-bit files, 64-bit files, and message translations. We're really only talking about 14 to 15 megs of files here. And so whether you have a 32-bit system or a 64-bit system, I think having the option of being able to run both is a good thing. Now, I personally do all of my work in the 64-bit side, but I have noticed that there are certain packages and certain quirks that sometimes I have to shift over to my 32-bit side. And that's the reason I would say just go ahead and install them all. Once you move forward through the installation process, just accept the defaults. I mean, unless you really know what you're doing, just go ahead and just keep installing the software the way that R wants you to install it. And also, make sure that you're associating R with the .r data files. And I would also recommend creating a desktop icon. I usually take that icon and then I pin it to the taskbar at the bottom so I can just get right to my software immediately. Once we've done this, we'll have a couple icons sitting on our desktop. In this case, we have RI386 and RX64. And the X64 represents our 64-bit version of R. The 386 is our 32-bit. So if you double-click on one of these icons, you're going to open up the R interface and the console. And this is what you're going to see. And I just want you to take a look at this console and just understand what is being presented for you. This will probably be one of the only times you will ever open up the R console directly. I find it working in R through the console to be a very tedious endeavor. I'm sure there are some people out there who perform their work directly through the console. I am not one of them. And I think you'll find as I'm going through this primer that there are a lot of good reasons not to do this. So with that said, go ahead and exit out of the R console. Now we need to go through and install RStudio. And RStudio is an IDE that is provided through a third-party provider that works with the R language. So we'll start in a similar fashion. We'll just Google RStudio, and we should find www.rstudio.com. And if you're fortunate enough to have a way to get to the download section straight from Google, just go ahead and click on that download. Otherwise, go through RStudio and go to the download section. Once we're in RStudio's website, find the latest version that coincides with our operating system. In this case, I'm using a Windows 8 platform, so here is the latest version of RStudio that works for me. But make sure you find the OS that works for the version that works best for you. Likewise, with our installation of R, go ahead and run the application as you're based off the prompt that opens up, and go through the setup configuration. Afterwards, RStudio will install in your program directory. I go to the programs and I find the executable file, and I just right-click it and I create an icon or a shortcut, and then I pin that to my taskbar in the same way. And this is really how I get into RStudio. Once you've done this, you'll find the RStudio icon. Go ahead and click on that, and that should open up RStudio. This is what you should see from a version that has no packages or anything else installed. This is the base setup. Here's an image that I found from the internet that kind of showcases what working in RStudio looks like. And you'll see that there are 4 distinct panes. I kind of like this graphic because there's a very nice scatter plot image of diamond pricing in the bottom right hand side. But this is, when I'm thinking about working in R, what interacting with R should be. And we'll get into the specifics of the RStudio environment in the upcoming slides, but I just want you to just be familiar with what this interface looks like. When we first enter the RStudio environment, it is very important that we're doing all of our development work in R scripts. You can execute files in text files, but to unlock all of the features of working in RStudio, and there's many great ones readily available, make sure that we're using the R scripts. And I'll talk about how to access them a little bit later, but I just want you to keep that in the back of your mind, that whenever you're working in R, this is where you're going to work. Now let's dive into the topic of RStudio as the IDE itself. When I think of RStudio, I'm thinking of these 4 panes that are sitting in front of me. And we'll call these pane 1, pane 2, pane 3, and finally pane 4. And just remember the order in which these panes are being presented, because we're going to go through each one of them in numerical sequence in the upcoming slides. If we're talking about the first pane, the first thing that I noticed is that at the bottom left-hand side of the R Management Studio shows the R console as it would appear in the base R environment. So if you remember when we opened up base R and the prompt that was in front of us in the R console and what we're seeing in RStudio, we see that it's exactly the same thing. And this is RStudio just showing us the R console. This section shows us the executed results of our code, as well as any error message in the execution of our code. We don't actually perform our work here in this section, but it's critical to review when developing in R. A lot of times what I will do is I will be executing my scripts and the analysis and the techniques from a different section, and I'll go down and I'll see what the results are in the console. And so looking in this bottom left-hand pane is something that I do frequently, and as you start working in R, you will find that it will be helpful. The top right section shows information related to objects, and in the R world, the objects are data frames, matrices, vectors, values, etc., which are being used in this particular R session. One helpful feature of the environment section is the ability to review datasets, and R calls them data frames after they've been loaded in R. After clicking on a data frame, the table will open up on the left window. So if I'm looking at this environment pane that we had talked about, you see the data section, and underneath we have data sets of churn, diabetes, test data, train data, and so on and so forth. Let's go ahead and just click on that arrow on the churn. And when we do that, we will see that a table will open up and we can actually review our data here. So I like this feature a lot because then I don't have to constantly be writing summary or data in R. I can just import my information and just move over to the pane, click with my mouse, and then just do a very broad review of the data that I'm working with just to make sure I've got everything in place. So it's nothing amazing, but it's a handy little feature I like. In addition, this pane also shows the history of the R code execution which has been run in the current session. This is more useful for programmers who are reviewing production level code. I don't really get into this often, and I prefer to follow the execution of the code in the console in pane 1 that we talked about. So if you have more of an IT bend and you want to understand the history of all the steps that you've run and be able to diagnose errors in your code, this might be a section that will be helpful for you. The pane at the bottom right-hand side of the R Management Studio contains a lot of useful features. There are many tabs up at the top. One of the tabs is the Files tab, and this allows for a review of exported files and an ease of access to the working directory and files contained within. There's a Package Viewer tab, and this section allows for a review of all the available downloaded packages and easy activation of the packages when you're working within R. There's a Plot Viewer, which shows any generated plots that have been built in the current R session, and an extensive help menu, which allows for any specific questions you have related to base R or the installed packages. I want to spend a little time just going through some of these tabs. The first tab that we're going to look at is the Package Viewer. And when you click on this tab, you will see a list of all the packages that you've installed. And once you've installed a package in R, it remains an option throughout your tenure. So these are just packages that I have installed on the left-hand side. And it gives me a name of the package, a brief description, the version that I'm using, and if I click on these packages, it activates them in the current session, so I can draw from the code underneath as I'm developing my models. The Plot Viewer, to me, is a very handy feature, and I really like this a lot. If you're working in the base R and you create a plot or a graph, it's going to open a separate pane in a separate window, and just getting that plot extracted can be somewhat of a tedious process. What's nice is if you click on the export button in the plot viewer of RStudio, you have the option to save the plot as an image. So you can customize, okay, what type of image do I want to save? In this case, we're looking at a PDF, some options available to it. And another one is copying it to the clipboard. And I like this one a lot because you can adjust the size of the plot directly in the bottom right-hand side. There's a little, at the bottom of the image, you see kind of like a little cap covering the bottom right-hand corner. If you click on this and drag this around, you can dynamically resize the plot that you've produced in R. And then you just go ahead and hit copy plot, find whatever document or email that you're working, and just boom, Control V, and you're on your way. Really a very handy feature. The R help menu is very extensive. And if you go to the help menu and just run a search for particular topics based off of the packages that you've installed, or if you want to understand nuances of working within R itself, you can go to this help menu. In this example, I'm looking at the help documentation that's included with the forecast package. And just by selecting on the forecast package, I get this documentation. What's nice because here I'm looking at an ARIMA model. It gives me a description of what the model is, some sample code of how it's used, the arguments related to this function, who had authored the package, certain references, and some practical examples of how to use this technique in your code itself. So if you're stumped on an area, go ahead and go to this help menu and start navigating around and see if you can find that critical piece of information that helps you with your project. The fourth pane I saved for last, and this is really the bread and butter of working within RStudio and R as a whole. There isn't a nice GUI interface that we use. There are some companies that are creating these GUI interfaces. I think there's actually a package in R called R Commander that you can use. But R is a scripting language, which means whenever we perform our work, we have to type out all the commands that we want R to perform. And so whenever you open up R, you're going to be going to this fourth pane, and this is where we're going to do all of our work. Okay. And RStudio really has kind of designed this pane to ease the process as much as possible. What I like about this section is it allows for us to develop the R code freely without executing the code sequentially as in the R console. If you're trying to perform work in the R console, you're going to find immediately that it's very cumbersome. I sometimes will write functions and I want to just see the work that I'm doing laid out in a very nice, neat fashion. And working in this particular pane allows for me to do this. As I had mentioned before, the R language allows the use of text and C++ files to be run. However, to use RStudio's incredible feature set, we need to make sure that we're working in R scripts exclusively. So whenever you go in underneath the File menu, we have that little icon that has the paper with a plus sign. Go ahead and select on that, and then select on your R script. A couple ease of use tips when you're working in R is you can create comments by putting the hashtag sign at the beginning of a line in your R script. And by doing this, you can put notes to yourself of, okay, what is actually going on in the code that I'm developing. And this is a very handy technique for programmers and people who are developing code, because if you are putting comments as you're reading through your code, you will understand, okay, exactly what the code is doing, what each steps are, and I think this will help to ease the burden that you have when you're developing your R scripts as a novice R user. So this is really a great habit to get into, and I would highly recommend doing so. It will shorten your learning curve significantly. Another ease of use tip is you can highlight an entire section of code that you would like to run in this script, and you can press Control-Enter to execute it, or you can select the Run command in the top right-hand side of this pane. This allows you to develop your models in an effective stepwise manner that cannot be done in the base R. There are many different ways that the R language can be used to perform statistical calculations, deploy machine learning algorithms, manipulating data, scraping information off of the web. The learning curve for mastering the R language is fairly substantial and can be rather daunting for inexperienced programmers. And this is one of the drawbacks of working with R, is you have to really dive in the deep end immediately. Rather than going through all the mechanics and nuances of the R language, I'm going to focus on the practical application of R scripts and give an overview designed to get you up and running quickly. There are numerous resources on the internet that you can use to find introductory tutorials on R. I'm sure you are going to come up with a number of questions as you begin the process of learning this language, and I would recommend that you draw from your Googling skills. Seek out the active R community and fork some code that is tailored to your problem. When building an R script, the basic format for model building that I use in R is the following. First and foremost, I set my working directory. I then load the libraries that are going to be helpful for the task at hand. I bring the data into R, and then much like the data set in SAS, this is where then I can go about my transformation of my variables. I then dive into the topic of EDA, which in our next presentation we will jump into that topic in detail, so I will save that for later. And from this we will create our summary statistics, and then we will split the data in a training test set to do our model building. Then we will build and evaluate our model. We will develop our model on our training data. Afterwards we tweak tuning parameters of the model. Then we evaluate the model performance on our test data. The next general step of our process is going to be then to apply our predictive model to the data that we're working with. In a business context, after we've produced our model, we want to show the results of what the model is showing, and we want to apply it. And finally, then we will export our results. So after we've applied the model to our data, we need to push the data out in some way. Now, I'm sure there are other aspects that we could get into, but for a novice R user, this is the general approach that I take when I'm building my models. One housekeeping task before we dive into building our R script is we should create a folder in our directory that contains our R model, import dataset, so if you have a CSV file, and export the resulting dataset back into this folder. This isn't necessary to be working with R, but I find that being well organized, and as you're developing numerous models and code, just having some type of organizational system in place is helpful. As you can see on the right-hand side, this is my folder structure. So in my documents, I created an R package folder or R project folder, and underneath this folder, these are my subfolders. Some of them are just scripts related to specific modeling topics. I actually have some of the work that I had done for Marion County in the city of Indianapolis in its own folder, and there are other components such as basic scripts and additional files and packages that I have in place here. I like it because having everything nice and organized, we can find the code that we need for the task at hand. And as you're working in R, you're going to find that once you've mastered a subject, having the code readily available can be very helpful in future projects. With that said, we want to set the working directory. And for our mock example, we're going to talk about building a decision tree. And the code that I'm using here, the set WD parentheses quotation mark and then the URL, points us to the right directory. Notice how I have the hashtag sign set working directory, and I give a little note to myself. And also note that the slash mark is reversed from what we would actually see in a Windows 7 platform. So these are some of the nuances of working in the R language. But if you take this snippet of code and just amend it to whatever directory you're working in, that will set the working directory of where your files are located. Most everything that we're going to want to do will require some form of a third-party package. There are a lot of aspects that you can use the base R for, but in reality we're going to need to use packages. A package can be installed and the library loaded through executing the following script. So install.packages, parenthesis, quotation mark, and then the name of the package that you want to install. Once you do that, in RStudio, what I like about it is it will automatically download any dependent packages that are dependent on this master package. So if you're going to go through the R console, you're going to have to type every single package that you're going to want. To load the package, we just invoke the library function, and we say library, parenthesis, ROCR, and then we're up and running. In rare instances, certain packages cannot be installed this way. For example, the TM package for text mining is no longer supported by CRAN. So to use this package, what we will do is we will find from the website or wherever we've obtained the package source, we'll download the zip file, and then we will install it manually through the RStudio interface. To do this, we would go through RStudio Tools, Install Packages, and then we just point the menu to the package that we want to install. Most packages we're going to install will be really through this command line code. Here is the code that we can use to load multiple libraries. Notice how for our mock project here, I have my note to myself that I'm now saying load the libraries, and then I've got just all the libraries that I'm loading throughout this. And there are quite a number of libraries that we're loading. By setting the working directory, we are able to load the CSV file through shorthand notation. The data set is called my data, and the less than and dash sign tells R to apply this as a data frame. So I want to just take a look at this in a little more detail. So we have a function on the right-hand side that says read.csv. Then we have a parenthesis, quotation, and then the name of the file, in this case. By specifying my data in front of it, R is going to go in and load this CSV and then place it into a data frame, which is just a fancy way of saying the table, and we're going to call it my data. I didn't write an equal sign. I wrote this less than and dash sign, and that's the standard notation that you're going to be using when working in R. And then if I want to perform work on this table, then I can start to invoke other functions such as the summary function. Now we don't have to do the shorthand notation, the read.csv and then just diabetes. We are completely flexible to specify the entire URL address of the directory in this case. So I just want you to know that once you've set working directory, R retains that information and you can draw from that in the code that you're developing. Data can also be imported and exported from a variety of sources instead of a CSV. The ODBC, HTML, XML, HEFS, text, XLSX, etc., etc. This is very important when we're talking about business level enterprise solutions, because we're not always going to be having our data sitting as a CSV file. Sometimes we're going to need to connect to our business intelligence or our data warehouse platform directly to pull the data in. Here is an example of a package that has been built called RODBC that allows us to connect directly to a Microsoft SQL server. So in this case, I'm invoking the RODBC library, and then I run some commands that say, okay, where is my SQL server? How do I connect into it? Then I want to pull a table from SQL Server and apply it as a data frame in R. So in this case, I'm pulling the table customer from my SQL Server, and I'm going to call this r.customer. That's the name of the data frame. So I can run my model, I can produce my predictions, I can apply it to this data frame. And once I've performed all this work, I can then take this information and append or update back to the SQL Server through the ODBC connection. So depending on what type of platform you're using, you may need to find a different package or a different code set, but I just want to show you that it is possible through a script itself to connect to BI technologies, work with the data, and then push the results back. Once we have our data loaded in R, we can begin the process of transforming variables. And much like loading a file into R and applying it as a data frame, we can perform operations on the variables themselves. This section is where we would address any type of data transformations, changing of variable types, removing variables, dummy coding, etc., etc. Now, if you notice, on the left-hand side at the top, I have my data, which is the data frame that I've brought in. Then I have a $sign. After the $sign, I have the name of a variable. And in this case, the variable I'm talking about is log pedigree. And this is a new variable that I'm just creating. It doesn't exist in the data set. But then I have my less than and dash sign. And on the right-hand side, I'm performing a log transformation. So the mathematical translation in our language, in this case, is log parenthesis, my data, $sign, pedigree. And pedigree actually is a column that exists in my data frame. So you can, in one step, perform this transformation and apply the results into a new column in the data frame itself. Another example down below is then I'm taking this my data $sign pedigree column and I'm removing it. And the syntax to doing so is spelling out null. And you see in the script that it shows it in blue. So in the first step, what we're doing is we're transforming a variable into a new variable and then removing the original variable. Okay. Then finally, the last step is we're going to take a variable called class in this case, and this class is a 0-1 integer. Okay, it's a yes-no variable. However, because it is a 0-1, R reads it into the data frame as a simple numeric integer. We want to tell R to change it into a different type of variable. In this case, I want to change it into a factor variable, which allows for different types of modeling techniques to be performed against it. And you can see the syntax in this case is I'm now changing it to a factor through the as.factor command. This would be the section that we would build our EDA. And this is where summary statistics, correlation matrices, scatter plots, all that good stuff. We're not going to get into it here, but just understand that as we're going about the model building process, this is the section that we would perform our EDA. An important aspect of model building in R is the splitting of the data into a training and test set. Here is some code that allows for the split of our data set into two subsets, okay, using a random split between 70% for the training and 30% for the testing. But one important thing to understand is this set.seed command. And this is telling the R language that, hey, when I perform this split, I want to be able to replicate my results exactly the way that R had performed it. So that 1, 2, 3, 4 part in the seed, you can change that to any number that you want, but understand that this is just allowing R to retain exactly how it had performed this function. Now when you're looking at the code down below, I'm not going to get into all of the facets of it. I think one thing that is readily apparent is that you can see some of the subtleties and the nuances of working with R. We're splitting data into a 70% training and 30% split, yet to execute that command, it isn't necessarily intuitive to a non-programming mind. Depending on the predictive model that we're using, we need to run some diagnostics that assess the performance. This code changes depending on what model we're using and what technique and the goals of our predictive modeling or machine learning. An important function in R is the predict function, which applies the model to the data. And we can see this predict function at the top, where we have our test data, $y hat, which is essentially saying that we're going to create a variable, and then we're going to run our predict function. In this case, our model is our pfit model onto the test data. And then we'll also define some parameters depending on the model that we're using. The resulting prediction work actually will sit in this y hat variable. So this is a good way to take the work that we've been doing and applying it to a new variable that we're creating, and then we can run comparisons between the actual known value of y and our predicted value of y. And there's all sorts of assessments and measurements that we can do from that. The final data set, test data, now contains our predictive analytics results. We will now export these results from the R program into a file that can be used in other software interfaces. Our SQL Server, Oracle, Tableau, Microsoft Excel, etc. In this case, I'm going to export my results into an Excel file, and this is a command that I'm using through the XLSX package. Okay, but you can send it to a CSV or however you want, and you just need to seek out the package and the code that will help you with that. I want to spend a little time talking about some additional R tips that will help get us up and running quickly. We should create an R script that contains snippets of R code that you've used for various applications and models. I like to think of this as a recipe book. So, depending on my mood, if I'm cooking for lunch, for example, maybe I want a sandwich. Having a well-organized cookbook, I can flip over to my lunch section, find sandwiches, scroll down. Okay, here's a panini recipe, and then just grab the syntax for it, and I'll be completely on my way. I find this extremely helpful. So as you're working through problems as a novice, a data scientist, or IT professional, have this recipe book that you can draw from, and it will certainly help you in the long run. Okay. And it's very rare to be able to remember all of the facets of code development. There's just so much to learn in the R language that you're not going to remember everything. If you're gifted and have an incredible memory, congratulations. I, on the other hand, do not. Okay, so I need to be able to refer back to this code. And another important aspect is that because these packages are being built by third-party developers, users, the notation and the language is different depending on what package you're using. So having this recipe book, I think, is the difference between being a good data scientist and being a great one. With so many different packages available, it's hard to find an exhaustive list. You can go to Google and you can run top R downloaded packages, and you'll find a very nice list of ones that are being frequently downloaded. Okay, but that doesn't necessarily mean that's going to help us with the predictive analytics work that we're doing, or machine learning work, on a regular basis. So I just want to give an example of packages that I'm using. So if you're just starting with R and you want to get some data mining, machine learning packages installed, go ahead and start with this list. It's not all-inclusive by any means, but I think if you can get these ones all in your system, you'll be well on your way. R allows for the use of parallel processing. This is particularly useful because of the manner in which models are processed in memory. It can be a drawback depending on the computer that you're using and the performance that you have. But if you've got a powerful computer with a lot of RAM, multiple cores, we can draw from this to our advantage. And I just want to talk about this a little bit. If we have a complex model that we're having trouble being processed in a timely manner, it's just taking forever to run, or if we have information that we want to take advantage of from our big data or our Hadoop HDFS system, the parallel package is certainly worth taking a look at. And what this allows us to do is to specify the amount of cores that we're using in the execution of our script. So if we want to tweak some of the hardware parameters, we can actually invoke this through the R language itself, and this is one package to do it. So if you need more horsepower for your R code, explore some of these packages, including the parallel package. This tutorial is only intended on showing some of the functionality of the R language through example. Please seek out the numerous tutorials available on the internet to build up your skills. This is not exhaustive by any means, and to be honest, doesn't even do the topic justice. Okay. Don't worry if you're struggling with getting your models to process at first. The language is difficult, and the learning curve is very real. Okay. But persistence, working through the code, understanding why I'm trying to run something and it's not working is part of that discovery process. And going through that process on your own, it's a personal journey, but you're going to come out as a better data scientist as a result. The payoff for learning the R language is incredibly great, and it opens up a full spectrum of statistical methods, web scraping, big data, and machine learning. If you can master the R language and know how to manipulate data and perform models and apply it, you're going to have a leg up over a lot of people. And I believe that the R language is going to continue to grow, and its adoption is speeding up. A lot of people talk about open source Linux versus Windows, and will Linux take over the world, and why aren't we seeing that? I do think, on the other hand, R, compared to some of the vendors of analytics solutions like SAS and SPSS, has a very real advantage, and the competitive advantage of a SaaS product is being eroded very quickly. And this is evidenced by looking at the types of skill requirements that the large tech giants are looking for in their data scientists. And if you just look at the job postings of data scientists, you're going to see R language popping up a lot, and for good reason, because it's amazing. Some of the techniques that are at the cutting edge of human knowledge and thought are unavailable in other software platforms today. We can use this information in R, and we get a first crack at it. So if we want to be on the cutting edge, R is where it's at. Good luck, and welcome to R.